Chinese automaker BYD unveiled its groundbreaking Super E platform, a next-generation electric vehicle architecture engineered to redefine charging speed, power density, and overall EV performance. Positioned as the world's first mass-produced 1,000 volts all-domain, high-voltage architecture for passenger vehicles, the Super E platform elevates core systems, battery, motor, power electronics, and thermal management to operate at unprecedented voltage levels. BYD claims that the platform achieves a peak charging power of 1 megawatt, enabling vehicles to add 400 kilometers of range in just 5 minutes, effectively matching the refueling time of gasoline cars. To support this, BYD has developed a comprehensive megawatt flash charging ecosystem, including a new battery chemistry, liquid-cooled charging terminals, and self-developed silicon carbide power chips. The first models to adopt this technology, the BYD Han L and Tang L, opened for pre-order in China immediately after the launch, with deliveries slated for April 2025. In the context of accelerating global EV adoption, range anxiety and long charging times remain significant barriers to consumer acceptance. BYD's chairman Wang Chuanfu emphasized at the unveiling that the ultimate solution is to make charging as quick as refueling a gasoline car, underlining the strategic imperative of rapid charging innovation. BYD's journey toward the Super E platform traces back to the launch of its original E platform in 2019, but it was the E platform 3.0, introduced in September 2021, that laid the critical groundwork for today's breakthroughs. Designed around 4 core pillars: safety, efficiency, intelligence, and aesthetics, the E platform 3.0 integrated the innovative Blade battery directly into the vehicle's body, doubling structural rigidity and enhancing crash performance by transforming the battery pack into a load-bearing component. Central to E Platform 3.0 was the world's first mass-produced 8-in-1 electric powertrain, which combined the vehicle control unit, battery management system, power distribution unit, drive motor, motor controller, transmission, and onboard charger into a single module. This deep integration reduced energy transfer losses and achieved an overall system efficiency of up to 89%. Alongside this hardware convergence, BYD introduced a domain-controlled electrical-electronic architecture, replacing distributed wiring harnesses with zonal controllers for powertrain, cockpit, and body domains. On the aesthetic front, the E Platform 3.0's skateboard chassis allowed for shorter overhangs, a longer wheelbase, and a lower center of gravity, resulting in a drag coefficient as low as 0.21 sec/day and significantly expanded cabin space. The hallmark of the Super E platform is its full-domain 1,000 volts high-voltage architecture, the first of its kind in mass-produced passenger cars. By elevating all primary electrical systems, battery pack, traction motor, power electronics, and even auxiliary loads such as air conditioning, to 1,000 volts, BYD achieves significant reductions in current for a given power level, which in turn lowers power losses by approximately 12% and enables thinner, lighter cabling. This architecture optimizes overall energy efficiency and thermal management under high load conditions. At the core of the platform lies BYD's newly developed flash charging battery, engineered with ultra-fast ion channels that slash internal resistance by 50%, allowing for charging currents up to 1,000 amps and a charging rate of 10 C, the fastest in the world. Unlike conventional module-based packs, the flash charging battery employs a simplified cell-to-pack design that minimizes passive materials and maximizes volumetric efficiency. This chemistry and pack architecture combination supports rapid lithium-ion transport while maintaining the inherent safety and cycle life benefits of lithium iron phosphate cells. Leveraging its 1,000 watts system and flash charging battery, the Super E platform achieves a peak charging power of 1 megawatts or 1,000 kilowatts, translating to an unprecedented charging speed of 2 kilometers of range per second and 400 kilometers of range in just 5 minutes. Independent tests have demonstrated real-world charging gains of over 407 kilometers in 5 minutes under ideal conditions, edging closer to gasoline refueling times and dramatically reducing charging anxiety for users. Complementing the battery advances, BYD introduced the world's first mass-produced 30,000 RPM electric motor as part of the Super E platform. This high-speed motor delivers up to 580 kilowatts from a single module and contributes to a top vehicle speed exceeding 300 kilometers per hour. Its compact design and high rotational speed significantly enhance power density, reducing motor mass and footprint by nearly 20% compared to previous generations. To manage megawatt-level power flows efficiently, BYD's self-developed automotive-grade silicon carbide power chips rated up to 1500 volts, the highest voltage rating in mass-produced silicon carbide devices today. These SiC semiconductors exhibit lower switching losses and higher thermal conductivity than traditional silicon IGBTs, improving inverter efficiency under high voltage, high current operation, and ensuring system reliability during ultra-fast charging and high-power discharge. Recognizing that vehicle capability must be matched by infrastructure, BYD has developed an all-liquid-cooled megawatt flash charging terminal system capable of up to 360 kilowatt output. The company plans to deploy over 4,000 such stations across China, each featuring dual-gun charging technology that can upgrade existing superchargers to megawatt speeds and integrate intelligent voltage boost to maintain compatibility with public fast-charging networks. Building on the domain-controlled EE architecture pioneered in ePlatform 3.0, the Super E platform continues BYD's transition toward a software-defined vehicle paradigm. Dedicated domain controllers for powertrain, cockpit, and body functions communicate over high-speed Ethernet backbones, enabling centralized processing of sensor data and coordinated control of vehicle subsystems. BYD's proprietary BYD OS decouples hardware and software layers, allowing for over-the-air feature updates, real-time diagnostics, and seamless integration of advanced driver assistance and infotainment functions. This unified architecture accelerates innovation cycles and lays the groundwork for future autonomous driving capabilities. The BYD Han L is the flagship sedan platform carrier for the Super E platform. Its EV variant offers single-motor rear-wheel drive and dual-motor all-wheel drive configurations. The single-motor model produces 500 kilowatts and achieves a CLTC range of 701 kilometers, while the dual-motor version delivers a combined 810 kilowatts, that is 230 kilowatts front plus 580 kilowatts rear, with a CLTC range of 601 kilometers. The dual-motor Han L sprints from 0 to 100 kilometers per hour in 2.7 seconds and reaches a top speed of 305 kilometers per hour, powered by an 83.2 kilowatt-hour LFP pack that supports 1,000 kilowatt DC charging, enabling 16 to 80% SoC in 10 minutes. The Tang L SUV shares the Super E platform's hardware backbone while offering both pure EV and DM hybrid powertrains. Its EV variant mirrors the Han L's charging and motor capabilities, while the DMI and DMP hybrids combine a 1.5 liters turbocharged petrol engine with 1 or 2 electric motors at 200 kilowatt each, supported by a 29.5 kilowatt-hour LFP battery for electric ranges of 170 kilometers for DMI and 145 kilometers for DMP. This flexibility demonstrates the platform's adaptability across powertrain types and market segments. While most current EVs operate on 400-volt systems and a handful of high-end models, such as the Porsche Taycan and Hyundai eGMP platform, use 800 volts architectures, BYD's Super E platform leapfrogs these with a full 1,000 volts domain-wide system. Tesla's latest Model S Plaid still relies on a 400 volts battery pack with peak charging rates around 250 kilowatt, illustrating the technological gulf that BYD aims to bridge. BYD's demonstration of 5-minute, 400 kilometers charging directly addresses consumer concerns about charging times, potentially accelerating EV adoption by alleviating range anxiety. However, scaling megawatt charging globally will require significant upgrades to electrical grids, harmonization of charging standards, and investment in high-capacity power delivery at charging sites. Additionally, the initial premium pricing of Super E platform-equipped models may slow uptake among cost-sensitive buyers, although economies of scale and technological maturation are expected to reduce costs over time. Beyond the Han L and Tang L, BYD plans to extend the Super E platform to luxury and commercial segments, including the Yangwang U7 SUV and the Denza N9 MPV, signaling its ambition to scale the technology across diverse market niches. The platform's modular design supports single and dual motor layouts, hybrid variants, and potential applications in buses and light commercial vehicles. As the global EV landscape evolves, the Super E platform's innovations will likely shape standards, infrastructure investments, and consumer expectations for years to come. Thanks for watching. Subscribe to the channel to never miss our upcoming videos.